Hello and welcome to my review of the Geometer Sketchpad, also known as GSP5. My name is Shane Newman, and I am doing this project for my MATE 4001 course. To begin, we have the selection tool. This selects things. You can click individually to make them, or you can hold and click this button, and you have the rotation tool and the dilation tool. We're just going to keep it with this right now. So also on this toolbar, you can move this toolbar actually, if you just drag, but I'm just going to keep it over here for now because I don't want to lose it. We have the point tool. You make points. You can use the selection tool to then select all of them and move them, select one of them and move them, select all and delete, which is in edit, clear points, or just the delete key. I'm going to use the delete key for ease of use. Now moving on to the compass tool, this will make circles. You first click this where you want the center to be, so I'm going to have the center right here, and then you drag out from that, and this will control the radius, this point that I'm dragging around right now. And then you click again to set it, and now you just have this circle. You can drag the circle around, and you can drag this point around to change the radius again, or rotate it. If you don't want to accidentally change the radius or the size or rotation, you can hide this point by going to Display, Hide Point, or you can just hit Control H. I'm going to hit Control H, and the point is gone. Now there's no way to change this, but now you can add points to this if you want. You can add a point, and you can drag this point around, and it won't change the radius. Even further, you can come to the line tools, and this will make segments as shown right here. You make a segment, and you can drag these around, these endpoints, or you can drag the whole segment itself. Now, also, you can use this segment tool to make it on the circle. That will make a chord. Now this segment is bound to the circle. It won't leave the circle if you drag these endpoints. You can also drag the whole segment. It won't leave. Speaking of these lines, let's go ahead and get rid of these. There are different types of lines that you can, or segment lines and rays. Here's the ray. You click, and then you drag out and click again. You can rotate it like this, or you can rotate it by doing this. Let's get rid of that, and we'll show you the lines. This is a line. You choose one endpoint and another, and it will show a line that extends out indefinitely on both sides. Here's the polygon tool. You can put multiple points down to make a polygon, and it'll be shaded in. So here we go. Here's the third, and it makes a polygon, makes a triangle, and now we're gonna make a quadrilateral. And if you click again, it will stop right there. Otherwise, it'll just keep adding points. So you have to click on the previous point that you just did, and it'll stop. So now it's a completed polygon, and we can move it around, or we can change it. And that's it for that. Now here we have a basic text tool. We can type anything here. We can change the font, the size, bold, the color, and right here we have symbolic notation button, which will bring all of these symbols and mathematical buttons that you would need. So for the marker tool, let's get a segment out here. For the marker tool, you can actually add dashes onto segments right there. So if there were two lines that were parallel, you can actually right click this and leave it as a open arrow. and you can drag this around if you need to. But if there are two lines right here that showed this, it would mean that the lines are parallel. So now I'm just going to go ahead and play with the tools that I just introduced. So I'm going to go ahead and make a circle, and I'm going to hide this point so I don't change the radius of the circle anymore. Now I can add a segment from the center, and now I have a segment that I can just move around this circle. But I can add another segment, and now in the interior I have an angle right here. Let's go ahead, I'm going to mark these points, and this is the center, and this is the other point. Now I have an angle of ABC. To see this, I can go ahead and mark it by clicking on the center and dragging out. And right here I have the angle marker. You can right click this and mark the angle, but for later use of transformations, but also you can just click on angle and it will show the measurement of the angle. You could also do it by clicking this, going up here to measure, and clicking angle, but I already have it, so I'm going to delete one of them. This will automatically update if I change the angle at all. What else I can do is if I make a new circle, hide this point again, I can create a segment from right here to from the center out, and I can create a set angle, a fixed angle, by just, let me label these again. So if I click the center and I go to transform and I mark the center, I can then mark that, and that will save that as the rotation point for this segment that I'm about to rotate. So I click the segment and the point that I want to rotate, and I go ahead to transform and I click rotate. Now I can do it by a fixed angle and just rotate it, let's say 45 degrees. Or I can do negative 45 degrees to get to the right, and I can rotate it. And now if I move this, the angle won't change. So let me mark this center, or mark this angle, measure it, and now I have the angle is always going to be 45 degrees no matter what I do. If I move the circle, if I move the center, if I move any of the points, it will stay the same. Now also what I could have done, I'm going to go to edit and undo. Just going to keep hitting undo until I get to the point where I did not transform it. Undo translate. Oh no. Okay, there we go. Now, if I want to rotate this again, I can rotate it. But I can do it on the marked angle. Now earlier we had marked this angle. So now this angle will always represent this angle. So since that angle is marked, I'm rotating it based off of that angle. So now if you notice, if I mark this again and measure it, these two angles are the same. Now if I change this angle right here, the other one will change with it, and they will always be the same. This is just some of the tools that you can use, some of the things that you can do, just playing around. There are many different transformations you can use. There are many different things you can measure. There are you can use functions. You can calculate right here. You can use the grid. You can show the grid on this. Now I'm going to go ahead and show a couple of examples of how this can be used in a classroom. So there are many different ways you can use GSP5 in a classroom, but one way is you can go to the help option, and under here it says sample sketches and tools. Now I went ahead and I went to the geometry one and I clicked on the Pythagorean theorem. Now I opened this, I clicked open, but I already have it open. So here you can see a visualization of the Pythagorean theorem. There are many ways. I'm going to go ahead and show this this way that students could understand the Pythagorean theorem more. So right here you have a right triangle. You have side A, side B, and side C. Now we know that A, if you square it, so length A times length A, it would make a square over here. Same with B, it makes a square. This is B squared and this is A squared. Now this is the same triangle that's just reflected. So what you can do is you can reflect the top, this top half. If you drew a line from here to here, just reflect this top half. So you can reflect it. There it goes. Now you can see it changes the shape of the whole thing, but it does not change the area at all. The area of the white is still the same. Now you can turn these triangles, you can rotate these triangles, and now you can see that the area of the two white squares were equal to this big square, which is c squared. So if you can see this, the white area used to be b squared and a squared, and now it is c squared. Now that's just one of the tools that you can use. There are other ways to show Pythagorean theorem. That was just one of them that I chose. Also, what you can do is you can show dynagraphs. If in an algebra class that you wanted to show students a dynagraph, there's a whole working sheet for you right here. This shows the proper, or just allows students to see what a dynagraph looks like. Now this one, it is a linear equation. I believe it's y equals 2x. So every time, like with every x you move forward, the y increases at double the speed. This one right here is x squared. It gets big very fast, but when x goes negative, y still goes big very fast, so that should be x squared. And you can show the tick marks for accuracy, and then you can also show the function information to see if you're correct. And under here, this pre-made tool comes with a make your own, so you can make your own dynagraph, and it shows the instructions.